Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hello everyone, let me introduce myself. My name is Ratu Talita Leticia Miranti from Taking Perkapalan, and today I will explain about my final project, my first task of my final project, which is my object is bulbous bow. So the first question is, what is the bulbous bow? Bulbous bow is part of the shape which is located in the bow. This section is an integrated part of the ship's hull. The bulbous bow is used as a device commonly used on a ship. So this is the picture of a bulbous bow. And then the second question is, who invented the bulbous bow? Bulbous bow were first discovered in the late 18th century by the United States Navy, which was originally introduced by David Taylor. The bulbous bow was used in 1912 by U.S. military ships and only commonly used on merchant ships around the end of the 50s. And then this is the type of the bulbous bow. And the third question is, when do we need to use a certain kind of bulbous bow? Basically, the bulbous bow can be used on all type of ships. With only a few exceptions, the bulbous bow has less effects on ships with low speed and small vessels. For ships with a modern hull design, the bulbous bow can save energy propulsion 8 to 15%. One of the newest designs is the bulbous bow with a gooseneck shape, with the tip bent upward. This type bulb has a length of 4 until 4.5% waterline length. However, the best results are produced when the length is increased to 5% LYL, especially for ships with a fruit number above 0.3. The sectional area is 6 until 11% of the midship area and can be taken at 9% where the tip of the bulb appears above the waterline as height as 40 centimeter until 60 centimeter. And then the next question is, where is the bow of the bulb installed? Bulbous bow is part of the ship which is located in the bow. This section is an integrated part of the ship's hull. Bulbous bow is usually installed in the main function of the section is to reduce ship resistance during exploitation or operation of ship. Most of the resistance on ship is caused by the presence of parts of the ship that are in direct contact with the fluid. The fluid that the ship passes through forms a wave pattern as a result of the movement of the hull, which ultimately causes friction with the hull of the ship. The working principle of the bulbous bow is to generate waves or interfere with ship waves coming from the bow, so that the incoming waves will lose power due to wave interference from bulbous bow. And in the end, the wave energy around the hull will be reduced. Thus, the ship resistance can be minimized. And then the next question is, why do ships need to use bulbous bow? Theoretically, a bulbous bow with a certain shape works by accelerating the flow of the fluid in the surface area above the bulb, causing an area with low pressure on the fluid surface. The low pressure area then reacts with the pressure waves in the bow, where the reaction is to reduce the effects of the waves coming from the bow, which in turn will reduce the pressure on the hull and reduce drag. In cases that generally occur, the installations of the bulbous bow can affect the value of the effective thrust needed to move the ship. This is understandable because, as it is known, that the effect thrust is directly related to the function, the amount of resistance on the hull, and the speed of the ship. And then the last question is, how does the role of bulbous bow for the ship? The role of the bulbous bow in changing the pressure and propulsions of the ship can be written with several reasons. In principle, they are follows. First, There is a reduction in pressure due to wave in the pressure-filled area by the bulbous bow, which then increase the size of the wave-making resistance. The second one is the effect of the upper part of the bulbous bow, and then the area where it is intersects the hull causes a decrease in the fluid flow component in the bow area of the ship. The third one, there is an additional friction resistance between the surface area of the hull and then the fluid due to increase in the surface area by the bulbous bow area. The fourth one is changes in propulsion efficiency by the role of the bulbous bow in the fluid flow area around the hull. And then the fifth one, there is a change in the wave breaking resistance. So that's all from me. Thank you and wassalamualaikum warahmatullahi wabarakatuh.